Hello students, today we are going to start the Z transform, its definition and some introductory points. Introduction: the discrete time Fourier transform (DTFT) exists for energy and power signal. Z transform for neither energy nor power, that is NENP type signal, up to certain extent only. The replacement of the Z is equal to e raised to j omega is used for Z transform to DTFT conversion for only absolutely summable signal. Suppose if you want to convert the signal from the Z transform to the DTFT, then if you replace Z is equal to e raised to j omega, so you will get the DTFT conversion. So the Z transform is the generalization of discrete time Fourier transform. It is used because DTFT does not converge or exist for many important signals and yet does for the Z transform. It is also used because it is notationally cleaner than the DTFT. In contrast to the DTFT, instead of using the complex exponential of the form e raised to j omega n with the purely imaginary parameters, the Z transform uses more general z raised to n, where z of n, where z is the complex. So that Z transform thus allows one to bring in the power of the complex variable theory into the digital signal processing. So this is the example power series of the Z transform, that is x of n. Z transform of discrete time signal x of n in the power series can be written as a x of z is equal to summation n is equal to minus infinity to infinity x of n z raised to minus n. So this is the equation for the Z transform. The above equation represents a two-sided Z transform. So this equation is also called as a two-sided Z transform. So generally we can convert the take the Z transform x of z is equal to by taking the Z transform of x of n. So we can make the pair, that is x of n. If you take the zt, so you will get the x of z, and if you take the izt of the x of z, that you will get the x of n. That is zt is nothing but the Z transform. Izt is nothing but the inverse Z transform. So if it is a continuous time signal, then the Z transform are not needed because the Laplace transformation are used. So for the continuous time signal, Z transform is uh, not needed because Laplace transformation are used. And however, the discrete time signal can be analyzed through the Z transform only. We may obtain the Fourier transform from the Z transform by making the substitution z is equal to e raised to j omega. So Fourier transform can be obtained by the Z transform. Only substitute the z is equal to e raised to j omega. This corresponds to restricting mode of z is equal to 1, and also with the z is equal to r into e raised to j omega. So if you replace the r into e raised to j omega in above equation, in this equation, so you will get the x of r into e raised to j omega, that is equal to n is equal to minus infinity to infinity x of n into r into e raised to j omega raised to minus n. So that is equal to summation n is equal to minus infinity to infinity x of n into r raised to minus n into e raised to minus j omega n. And this is that is the Z transform is the Fourier transform of the sequence r of x of n into r in raised to minus n. So Z transform is nothing but the Fourier transform of the sequence x of n into r raised to minus n. And for the r is equal to 1, this becomes the Fourier transform of x of n. So the Fourier transform therefore corresponds to the Z transform evaluated on the unit circle. So it can be represented by this figure. So x-axis represents the real part, y-axis represents the imaginary part, and z is equal to e raised to j omega. So this is the z plane. The inherently periodicity in the frequency of the Fourier transform is captured naturally under this interpretation. And the Fourier transform does not converge for the all sequences. That is, infinite sum may not always be finite. And similarly, the Z transform does not converge for all sequences or for all values of Z. and the set of values of z for which z transform converges is called the region of conversion. The Fourier transform of x of n exists if the sum is equal to n is equal to minus infinity to infinity mod of x of n converges. Then and then only Fourier transform is also converges. Here, however, the z transform of x of n is just a Fourier transform of the sequence x of n into r raised to minus n. So that is Z transform therefore exists only if x of z is equal to summation minus infinity to infinity x of n into r raised to minus n less than infinity, and this leads to the condition summation minus infinity to the infinity mod of x of n into mod of z raised to minus n should be less than infinity for the existence of the z transform. So this is the condition for the existence of the z transform, and that is nothing but the summation of the x of n or summation of the sequence should be less than infinity, and the ROC therefore consists of a ring in the z plane. So this is the region of convergence of in the z plane, and in specific case the inner radius of this ring may include the origin, and the outer radius may extend to up to the infinity, and if ROC includes the unit circle, that is mod of z is equal to 1, then the Fourier transform will converge. And the most useful of the z transform can be expressed by its transfer function x of z is equal to p of z, that is divided by q of z, where p of z and q of z is nothing but the numerator and denominator in the z polynomial. And if the values of the p of z is equal to 0, that is numerator equal to 0, are called as the zeros of the transfer function or x of z, and if q of z, that is denominator equal to 0, are called the poles of 0, and the zeros and poles are completely specifying the x of z to within a multiplicative constants. So let us take the right sided exponential sequence. Consider the signal x of n in that is equal to a raised to n u of n. This leads to the z transform, that is equal to x of z is equal to summation minus infinity to infinity a raised to n into u of n into z raised to minus n. So that is equal to n is equal to 0 to infinity, because there is a unit step function and it is available for 0 to the infinity. So n is equal to 0 to the infinity a into z raised to minus 1 raised to n. So that is nothing but summation n is equal to 0 to infinity mod of a into z raised to minus n raised to n should be less than infinity. So in this case, mod of a into z raised to minus n less than 1, or equivalently mod of z is less than mod of e. In this case, the series will become summation a into z raised to minus 1 raised to n, that is equal to 1 divided by 1 minus a into z raised to minus 1, that is equal to z divided by z minus e, that is mod of z is greater than mod of e. Since it is just a geometric series and the z transform has a region of conversion for any finite value of e, so that is a is plot on pole is plotted on the real axis, and outside of the A, all is the region of the convergence. So that is a unit circle. And here the Z transform has the region of conversion for any finite value of A, and the unit circle is included in the region of conversion. So this is the right-handed exponential sequence. So let us consider the Fourier transform of x of n only exists if ROC includes the unit circle. So in this example, the Fourier transform is existed, and which requires mod of a is less than 1. But if other end mod of a is greater than 1, then ROC does not include the unit circle, and in that case the Fourier transform does not exist. And this is consistent with the fact that for these values of a, the sequence a raised to n u of n is exponentially growing, and the sum therefore does not converge. So let us take the left-sided sequence, that is towards the negative infinity. So that is x of n is equal to a raised to n u of minus n minus 1. This sequence is a left-sided sequence, that is summation minus infinity to infinity minus a raised to n u of minus n minus 1 raised to z raised to minus 1. So that is equal to So minus summation minus infinity to minus 1 a raised to n z raised to minus 1. So that is equal to the summation minus summation n is equal to 1 to infinity a raised to minus n z raised to n, that is equal to 1 minus summation n is equal to 0 to infinity a raised to minus 1 z in raised to n. So that for the mod of z raised to 1 mod of a raised to minus 1 into z less than 1, that is mod of z is less than mod of a, that is series convergence to the. So by calculating this, so you will get the z divided by z minus a, that indicates mod of z is less than mod of a. So the pole a is plotted on the real axis and mod of z is less than mod of a, so ROC is in the below the A point. So the this ROC does not include the unit circle, so the Fourier transform does not exist here. So this expression for the Z transform and the pole zero plot is exactly the same as the right-handed exponential sequence. Only difference is the ROC. So specifying the ROC is therefore critical when the dealing with this Z transform. So let us take the sum of two exponential sequence. So the sequence is 1 by 2 raised to n u of n plus minus 1 by 3 raised to n u of n is the sum of two real exponentials. So take the z transform of this, that is summation the sequence into z raised to minus n. Multiply this z raised to minus n into the bracket. So you will get the summation 1 by 2 raised to n u of n z raised to minus n plus summation n is equal to minus infinity to infinity minus 1 by 3 raised to n u of n z raised to minus n. So you will get the, you can minimize the complexity of the example, that is summation n is equal to 0 to infinity 1 by 2 z raised to minus 1 raised to n plus summation n is equal to 0 to infinity minus 1 by 3 into z raised to minus 1 raised to n. So for this example, the first term mod of z is greater than 1 by 2, and for the second term also mod of z is greater than 1 by 3, and so ROC is greater than 1 by 2 as well as greater than 1 by 3. So by simplifying this equation, you will get the 2z into z minus 1 by 12 divided by z minus 1 by 2 into z plus 1 by 3, and the pole 0 plot will become, so it is greater, this is the 1 by 2 pole and this is the 1 by 3 minus 1 by 3 pole, and these are the two zeros here. So the unit circle included in the ROC. So the ROC is greater than 1 by 2 as well as greater than 1 by 3. So the region of convergence includes the unit circle. So the FT will exist. Finite length sequence. Suppose take the example x of n is equal to a raised to n for 0 to n minus 1 and it is 0 otherwise. So take the z transform, that is summation n is equal to 0 to n minus 1 a into z raised to minus 1 raised to n. So that by simplifying this equation, it is 1 divided by z raised to minus n by n minus 1 into z raised to n minus a raised to n divided by z minus 8. In this, only finite number of non-zero term, the sum always converges when a into z raised to minus 1 is a finite. So there are no restrictions on the mod of a is less than a, and the ROC is the entire plane except z is equal to 0, that is origin. And the roots of the numerator polynomials are zk is equal to a into e raised to j 2 pi by k, for the k is the integer which is from 0 to n minus 1. Since this value satisfy the equation z raised to n is equal to a raised to n and k is equal to 0 cancels at the pole z is equal to a. So there is a no pole except at the origin, and the zeros are at z is equal to a into e raised to j 2 pi k divided by n, for the k is equal to 1 to n minus 1. So ROC is nothing but the region of convergence, is the range of complex variable z in the z plane. The z transformation of the signal is a finite or convergent. Therefore, ROC represents those set of the values of z for which x of z has a finite value. Thank you.